Is it recording? Yeah. So sorry, I've started my class, and are you able to hear me clearly? Am I too fast? Is it breaking up? Anybody can just confirm. Hello.
Yes, sir, I can hear you.
Okay, great.
Yes.
So there's a lot of data being generated, and a lot of businesses are running on data. In the sense, everybody wants to know. Who's going to win the election, what is the most used product, what is the most watched video. Lot of like data has been created. They say data is the new oil. Before, people are fighting for oil, but now they are fighting for data. Okay, they want to know. Basically, when they're fighting for data, what they're trying to say is, I want to know something. You have so many Facebook users. They want to know from Facebook what type of users are there on your platform. How many people. They want all the demographics. How many people are male, female, young, old. They want all combinations. So the thing is, the person, how much can a human being do? So that is why a human being has a limit. A machine can do much more, much better, obediently, without using. Of course humans will be there, but the better use of humans is to them to use machines. So we still need humans, but and humans can have to be, they can use their time, in decision making. So ultimately, this data has to translate to your decision. If your data is there, it's like, data is there, but the data cannot help you decide what is the use of the data. Right? So it should help you make some decision which will benefit in some way. So most of the time in businesses, definitely so what kind of decisions are we talking about? We're talking about is there a fraud in the credit card transaction? There's so many transactions happening every day. So many people are using Paytm and everything. How can we catch a fraud? Can a human being literally sit and watch for everything? So you need automated programs in between, not only to pull that data, but to analyze it and show it. I can just not show somebody a text format data. Oh, there is this transaction, or there is some data has come from here to there, and this is what happened, and we cannot explain in terms of text. And that is why the graphical view is so important, and that is where BI is coming into place. It helps you with the graphical view. So what is the challenges? Then definitely there's a huge data. If I said 80% of the data is generated, terabytes of data is generated. Where are we going to store the data? Any computer will have a limited space, right? Usually our laptops might have, maybe for example my laptop has 1 TB, but even 1 TB is less if I expose this computer as a data collection center to the entire internet, right? If Ola has to Ola Uber has to reach out to everyone all over the world, a small app can reach everyone in the world. So that is how businesses have changed these days. You can make businesses out of little apps and using less money. If my app is kind of connected to a server which is absorbing the data, how can it survive if the hard disk space is not there? So storage also becomes a problem. So when you're talking about data analytics, it is not only about the collection of the data, but it also where I'm going to store it. Do I need 1 TB hard disk? If I need 1 more TB, then what should I do? And that is where the cloud comes into place, where cloud is dynamic. You don't have to use the machine when you're not needed. You don't have to pay for the machine when it is not needed. So you can just keep on creating machines programmatically. So you're basically creating infrastructure using a code. It is called infrastructure as a code. So some time back Priscilla mentioned about cloud formation. So cloud formation is all about creating everything, whether it is machines, whether it is configuring the softwares, whatever you want to do, you can. It is more it is used for infrastructure and platform, your creation, the cloud formation service in AWS. So so cloud is one of the solution. Okay, I cannot get a machine immediately, keep on buying machines, because machines are going to get old, and then what is the use, after sometimes it will get obsolete, then I buy new machines. So all these issues are there, and then you have to protect the machine also, protect the data also, then you need people who will manage the machine also. So cloud comes as an answer, that you just pay for whatever you are using and any part of the world. So AWS cloud is definitely one of the top providers. Azure is in the market also, but Azure is connected to Microsoft, and it is focused on mostly Microsoft products, you can say. .NET is definitely one of them. The latest in .NET is .NET Core. So that is one of the platform. Then they have they're trying to get into smart cities, and they have a nice product called HoloLens, which is like a hologram, and especially they've given it to the US Army, where the soldier puts it on his puts that glass, like a virtual reality glass. It's not like a virtual reality glass, it is actually gives you a 360-degree view of how things are and everything. So that is something different, but the idea is everybody is getting on the cloud, and nobody has time, or nobody can afford the growth. So that is why everybody has to move fast, has to get the product fast, the cost has to be low, and that is why cloud is definitely used. And the data flow has to be very smooth. So if there is lot of terabyte of data is coming, you need to have a plan. It is like a big the big river is coming down, lot of water is like just flowing down the mountain, and you need to have proper dams all over the place, so that that those things are channelized properly, and then you collect them properly, so that you don't lose the water also. It is like your water harvesting, right? You get the water from the rain, you make sure you channel it through the pipes, and it is in the storage. From the storage you send it to the right place and everything. So everything works, just like river systems. You require a good kind of interconnections and proper smooth flow, so there is no bottlenecks also, right? If my machine is too slow to collect the data, my data must be generating at a speed of let's say 10 MB per second, but my machine is too slow that it can absorb only 1 MB per second. It can absorb only that much. That means what will happen to the rest of the data? It can get your data can get lost in the network, your packets won't be received. So speed is also important. So that is where this big data also comes into place. So what is big data? Big data is all about lot of data, and it is all about answering the trying to collect this data, channelize this data, manage this data, and give it to the right parties. So who will require the data? So one is the decision making team will be requiring the data. They want to get the reports, daily reports and everything. So, and that is where it has to be channelized. That is one client, that where the data has to be channelized to them. The second, you want it for all your customers on the websites and everything, what is happening and everything. So the customer, they deal with the accounts and profile settings, or whatever number of customers are getting added every day. So your website that also becomes your client. Then third thing is somebody wants to not only decide, but decide based on a prediction. So that is where your data science would come into place. So data science would apply machine learning techniques and artificial intelligence technique, deep learning techniques, neural network techniques. It is all about what is that area, data science. Data science is all about that. Basically it is using your statistics and mathematics. Okay, this much of data is there. What is happening in the data? Somebody is trying to understand the data. The machine is trying to understand the data based on some mathematical formula. That is what the data science area is all about. So data science is not about exactly data collection, data channeling, data reaching out to all the customers, all types of clients. That is that can come under data analytics, but data science is an extension of that, definitely mostly into the science of data, you can say, or trying to gather the meaning out of the data so that you are ahead in the market, so that you can be better. The machines definitely these days, the machines, if you have to teach them, how can you teach the machine? Either you teach them with the data that you have, or the machine has to learn. So there's so much of things are happening, how fast a machine can learn also, or how much a human being can teach a machine. So it has to be done in the whole process has to be done in a scientific way. We can give some formulas to the machine and say, okay, this is what the formulas are. There are six techniques. There is some data we have. Okay, this is the data. You just try to learn something from it. So that is one area. So when you are when you are saying that what you're focusing on, you be clear what area you want to focus in. If you are looking into BI, then you're definitely looking into the visualizations of the thing. So visualization, and it is like reports, right? So in reports, we don't see all the data, right? If there are 1 lakh records in the database, we don't see everything on all the records on the screen. What is more important for us is good decision making numbers. So what can be a good decision making number? It can be how many students are there, what is the rate of growth of students in a particular college. I will be covering the basics. I'm just it's just kind of, I'm just going with the flow and giving a knowledge. So I'll be covering the basics first only, fundamentals of databases. So I'll not be jumping to data science, but I want you all to understand all these pieces. Don't be confused in the sense, what am I learning? So it is not only about SQL. Definitely SQL is used to query the database and pull the data that you want. That is fine. But what is data analytics? If I want to make a career as a data analyst, what work I'm looking at? That is what I want you all to understand. If you are looking at data analytics, you are looking about collection, storage, channelizing the data, sending it to the right parties. At that point, your data science begins. Your data science now takes this good data that you have created and given it to them on the platter, and then it will try to apply some science and say, let me see now what is the prediction I can make. So we will use machine learning techniques over there. And of course your visualization, the task of the visualization is to give a breakup. This many males are there, this many females are there, and this country is better, this carbon emission is so low. It has to be given in such a way so that just looking at it, I can judge, I can decide, I can, and it will help me. If your output can help you decide faster in a second without manual intervention, that is a good output then. But collecting this data, that can be a problem. If it is a simple database, just a one database connection is fine. If it is coming from one place, it's fine. It is going to be much of a simpler task. Even that I will feel it is difficult, but considering that data is coming from everywhere, so data is coming from your phones, your websites, your all types of devices are there, and everybody is on there. Your sensors, IoT sensors are there. Like let's say in your house itself, if it's a smart house, then it will have a smart AC, smart devices which is kind of checking for temperatures, and if there's anything going wrong, it has to report somewhere, right? So it has to send the data. So even IoT devices with these sensors can send the data to the main server or the main database, and that data also can come from that direction also. And so I hope you all have understood some some difference between data analytics and data science. So this course is mostly focused on data analytics. It is not focused on data science exactly. Data science would be mostly into machine learning and into artificial intelligence. If that area is that is one big area. Of course, you should know data analytics, but that data science is that one area is a separate area. So in any system, it is always good. At least for me, I just want to know. I know as an architect, I just want to know where the things are coming from, where the things are going. Which client, what are the clients. That is more important. I don't have to get on as an architect. I don't have to get into the depths of how you make the prediction. That is a separate subject area and separate skills area. So before I move with the fundamentals of database, I want to know if anybody has any questions. Anybody has trouble understanding my language? Am I too fast? Is this something useful? Whatever you all have heard so far. So, are you able to understand whatever I'm sharing?
Yes.
Okay, so that's good. Thank you, Sarah. So
Yes, sir.
okay, great. So let me start my. So know your goals, okay, before you start. Otherwise, you're just not learning and you don't know where your goal is, no. So the kind of jobs that you want to look out for is, actually, any job is an opportunity. So I do not know what decision you should make, but it's okay if you all want to, take up any job, but better it be a IT job. Whatever job you want to take. Otherwise, it's going to become difficult to switch between non-IT and IT. And strategically try to approach. If you are very interested in specific area like data analytics, then data analyst role. Usually I'm saying that is kind of positions they create, or a data engineer, or maybe a cloud data engineer, something like that. Anything relating to data focused. So you have to look out for companies who are dealing with data analytics. And I already shared all the, I told you all how to search for the job, right? Just go on Google Map and type data analytics companies. So if you, so I'm just going to put it in the window, in the message window, and that is how I looked out for. So, and of course you get in touch with all these people who are already working, and even I'm going to try to I'll try to help you all in getting a good job. Of course I would like to know more about your interest and whether your interest is still persisting. So for example, Prajakta, initially she thought she wanted to do front end, but later after she got exposed to a little bit about databases, she said this line is very interesting and she wants to get into that line. And she is in the non-IT line, and because of whatever reasons, all this COVID had come in, and there were a lot of challenges people faced, and so she wants to get into the IT field, and she's really looking out for that opportunity. So she moved away from front end to data analytics. So this is a new area which has suddenly she has got exposed to, and she wants to want to see if there is any opportunities coming out of this, and that is why she joined this. That's why I started this course, and that's how this led to opening in this course for everyone. Okay, so as I said, data analytics companies, you search it in Google Maps, so that for example, if Saili is in Pune, she searches, she sees, okay, there are 10-20 companies. So go to each of their websites, see the career option, is there any job openings there, send an email, send your resume, keep your LinkedIn profile up to date. At the same time, keep learning, keep upgrading your skills, whether you get a job, whether you don't get a job. So this skills will never be enough, knowledge will never be enough. This field keeps on expanding, and so learning, whether you have a job or not have a job, should not make a difference. But participate in projects, hackathons, so that you all can go in the interview and put it on the paper, say I did this, so that they can get impressed. Because people, they don't, not every company is having a well-paying budget. Most of them will be like a startups or something. So if you want to get a job in that kind of company, they will definitely, first of all, they don't have a good financial base. So they will say, I want the best. I want to see. Of course, they look out for the best, but it's not so easy to get people also. No? So they want to, even if you are having some knowledge, how to impress them. So you definitely, your certifications will help, your skill set, practice. To try out simple things, because unless you put your hands on things, you will not get a feel of what is happening, what are the challenges I'm facing, where am I lacking, or what I need to study. You will get a direction only after putting your hands on. So try experiments. It's just not about knowledge is definitely one thing. If you understand how everything is connected to each other, you try out some experiment and you learn something out of it. And once you learn something, it goes on your resume that I did this. Even if it is a small project, even if it is a simple stuff that you do, it goes on your resume, and that kind of builds up your potential to get the job. That's what people are looking. Okay, this person has done this. Okay, so for example, if you told me, yeah, I've done SQL, I've done programming language, I've done this kind of experiments on this, I'm exposed to this cloud. What you have done at the end of the day, and how that can be used in the company, and that will define on whether you get a job or not. So you have to be better. At least you have to know whatever area you take in is. It's not very difficult. I'll say just build your knowledge and get into better. You have to be in the top. You can say minimum top 25. Top 25% of that lot. You have to be the top 25% lot, and you have to become top 10. And when somewhere in the top 25, I will say that much knowledge. At least you should have the knowledge. You should be better off when there is competitions going on. For the job and everything. So people should see a value in wanting you to win. I want you to join this company. I want you to work on this. And look out for the things that you are interested in. As I told you, if you're interested in data analytics, search for these jobs, and through your network, through LinkedIn, whatever works out. Look out for fresher kind of jobs also whenever companies, because those are the highest chances of getting the job. If Infosys is coming up with a fresher batch, just look out for it. Infosys, a lot of students who have interacted in the past, who had a trouble getting jobs maybe for quite some time. They almost everybody has got into Infosys. Most of them who got in touch with me, and they tend to take that knowledge, and then they go into these companies, and the chances increases. So increase your chances of getting a job. Be better. Even if there is no job, become better. Job does not necessarily make you better. No, increase your skills and everything. So make sure you are upgrading yourself throughout your life. Let me share my screen. And maybe I'll just go off the video just to save the bandwidth. How do I do that? Okay. Is everybody able to see my screen?
Yes, sir. Yes, sir.
Okay.
Yes, sir.
So initially I wanted to teach data analytics, yes, but I felt if you all don't understand databases, it can become a problem, and I'm not sure what kind of exposure you all have. What is am I teaching too basic? So you all have to let me know. This is just, we can skip such a topic or not, but I'm assuming from my perspective, there are a few things which I look out for, which is important, for me to deal with databases or think about data. So that's why, from my perspective, from my experience, whatever I can, give you all and train you all, I'll try to, train your minds, and you all can think from that perspective, and it will become easier, to get into any field related to data. So that's why I felt we should go through these fundamentals of databases. I was supposed to start this course maybe few weeks down the line, like maybe 2 weeks from now, but then I said, let me just at least go through the database part, and then we'll get onto the tools and everything. In this case also we'll be using the tools, because we will be using databases. Okay, so this first slide talks about what is data. So what I want, before I talk much about it, I want you all to tell me, each one of you, when you hear about data, what is data for you? So you can start in the same order, you'll introduce. So maybe Priscilla can start. What is data for you? What when you say data, what you think? Okay, this is what it is. What do you visualize?
So a set of information of a particular category or something. It can be any category, but a set of information.
And so who was the next person who introduced?
It may be text, number, observation.
Okay, text, number, observation. Very, very good. Okay. Next, well, I think Vasant. Did Vasant introduce?
Yes, it can be facts, observation, or same as this.
Okay. And yeah, go ahead, Prajakta. What is data? What comes to your mind?
Sir, data is a collection of information. It can be in different forms.
Okay.
So lots of varieties here. Yes.
Different forms. When you say different forms, means what are you trying to say exactly?
Just as somebody says that it can be in text, numbers,
Okay.
lots of types are there.
Okay, you're saying there are different types of data. Different.
Yes.
Yeah, data is something is text, something is a number. Okay.
Yes.
So that is okay. Yeah. So Sarah, what is data for you? What comes to your mind whenever you have studied, or what data meant for you?
Data means raw information.
Raw information. Okay. When you say raw information, means what? Why it is called raw? Why is it?
Means such as text, number, images, symbols, and all. When this information is processed, we will get knowledge about it.
Okay. So you are saying when the symbols, text, everything is processed, you will get an output, which is what did you say output is?
Knowledge.
Okay, like information you will get. Okay, this is what the data is, something like that. Okay, good. And Saili, when you hear about data, what does it mean?
So data is a collection of information. It may be text, number, figures, or facts, observation. Sometimes data is in a structured format, unstructured format, or semi-structured format. It comes with sometimes it comes with the images also.
Okay.
So it may be in a mixed format also.
Okay. So good. You all are having some understanding. So one of the this word is this word raw, right? Raw basically you can say original or origin, where it is starting from. So data is getting generated everywhere actually. So for example, This if you look at a particular photo, that photo is a collection of pixel. The pixel has properties like the location on the screen where it, or location in the image where it is at the this coordinates, and what is the color, right? So color is again made up of red, green and blue. How much is the red component in that? If you look at any color, every color, I don't know whether you can see this over here, but anyway, so every color is a combination of red, green and blue. If you mix red, green and blue all together, it becomes black. Sorry, it becomes black. Yeah, it becomes black. And if when you don't have red, when you don't have green, and when you don't have blue, what color it becomes? White.
White.
So you are having all the colors combination in the between, and you give a certain number to every color. Every color is nothing but a representation of red, green and blue. And so data is there in your image. So if I write a program like this, main, so this is my Java program, let's say main Java int I is equal to 10. What all data you can see in this program? Only in this program, what all data do you see? What type of data, what format of data, whatever you mentioned, text. Okay, so I can see text in that, but yeah, that is data, but it is raw data, you can say. Definitely it is original data, I mean, this is original data that has been created basically. So what else you can see? So I can definitely say a program is the data, right? So a set of programs becomes your data also. This also program is the data. What else? What all other data that you see on this box, inside this box?
So there is a variable
Very good.
which is in the integer format.
Okay. So a
And,
set
we have
of
assigned it
variables or variable itself is the data. The variable I is used, no? So the variable I itself is the data. Very good. And what else you see? So program is one thing you see, variable is one thing you see. What else do you see in the program?
Number is another data. Number is also the data.
Oh, okay, very good. Okay, so this number is 10 is given, but it is still a data, and only at this point I is equal to 10, I becomes 10. I mean the data is assigned. So until that data 10 is unassigned, but that also can be considered as a data. What else? What else data, other data that you see? If a compiler wants to know whether this program is correct or not, how does it do? How does it do the parsing? It has to look out for whether there is syntax error, whether there is semantics error. So how does it do it? It tries to break up this program into your symbols, right? So there is if your main function has to be there has to be open bracket, close bracket, there has to be kind of curly braces, open, close. These are all symbols, right? Symbols of the program is used as data by the compiler. Compiler is basically converting this high level language into machine level language, right? So your machine can run only machine language, so it has to be converted. So this high language is not what machine understands. Ultimately your machine understands a binary language, and that binary language is made up of binary commands, and so everything has to be converted. So these symbols also can become your data. What else can you see in this box? Any keywords are there? Set of keywords. What are the set of keywords used in this program?
Main.
Very good. Main is a keyword. You cannot use main anywhere in the other than this area. Then what are the keywords?
Int.
Very good. So int is main, and int is like keyword. So it's a set of keywords. So not only when you're looking at this program, there's a lot of data that is used by different clients. When I say client, means some program is using it, somebody who's using it. Here one person is trying to provide a service, another person is trying, the client is trying to receive the service, server client kind of thing. So here you are serving somebody with this program, and there is a lot of data in that. There's a set of keywords, there's a set of variables, there's a set of constants, there's a set of symbols, like symbols, and the program itself containing everything itself is a data. And this program is used by maybe a Java compiler, and you create a kind of a binary program or your bytecode out of it, and you run it. So that is a program, and then when the program runs, it throws an error. So is error the data then? When the program throws an error, or when a program gives a message, is that a data? So errors and messages are generated after you run the program. That means it was not there initially, it was generated after you ran the program. So will that be considered as data? Anyone? Vasant?
Yes, sir.
The errors and messages, did you hear the question? Errors and messages?
No, sir.
Okay. What I'm asking is, when we run the program, sometimes it throws an error, right? It says you have not initialized a variable, or it says, oh, you
Yes.
have done everything successfully. That is a successful message. Is that a data? Is the error message a data? Is the successful message a data?
Yes, sir.
Okay. So the answer is yes. So this kind of data is usually, we want to analyze. There are, you have a big application, and errors are thrown from everywhere. Your program sometimes are successfully running, sometimes they're throwing an error. How do you know? So sometimes they have the logs. They report everything into one particular log, and but that log data itself becomes your data then. But it is used for analyzing, for looking out for any particular problem. So so that also becomes your data. What I'm trying to emphasize is, data is everywhere. Text data is one thing that you're talking about. When you are talking itself, you're creating speech data. If a computer is absorbing that, it is a speech data, it is audio data, it is a video data. It is not only text and numbers, it is also videos, images, or maybe somebody is liking a post, somebody, whatever, any kind of statistics. Data is constantly getting created in all formats everywhere, either through the systems or of course we are mostly focused on the IT part of the thing. That's why we're not talking about the data that is generated elsewhere. Ultimately, if it has to be used in the IT, it has to be converted into binary format. So I hope you all have so that was one. We spoke a little bit about data. So I just I don't want to get on to something connected to data. I want you all to tell me. So there is a program. I say int a is equal to, let's say, something x, or say let's say 1, b is equal to 1. I want you to tell me what is the difference between this data and this data. Is there a difference?
First value
So first one,
is a string value, second
String.
is an integer.
The number value.
Very good. So if you all know what is string, so that is a good thing. At least you all know what is string. String is like a text. So anytime when you're seeing something within the quotes, you have to assume that it is a string number. 1, it is not a number. So you can apply mathematical formulas on a number type of data. So it depends on the data type. So one is of string data type and another one is number data type. So very good. Okay, let me see. Okay, it was slideshow. So it says in computing or in computers or in IT, well, data is information that has been translated into the form that is efficient or for moment or processing. Okay, so ultimately data is everywhere, but if you cannot convert it into a meaningful information or it does not help you in any way, it is useless. If the data is incomplete also, let's say there is data and you want to create information, just like let's say I want to register for Aadhaar card, but somebody is just giving me the first name. So my name is James, so by my name James, can that information, Aadhaar card, Aadhaar number can be created? No. So it's useless data. So we cannot work with useless data. There's a word called GIGO, right? Garbage in, garbage out. If you give garbage data, you will get garbage out. You have to make sure, apart from first name, the last name is given, the thumbprint is given, the eye scan is given, the pad, your whatever your signature is taken, your address is proof is given. All this data is connected, and then you can create some meaningful information out of it. Your data has to be clean. So that is where your data science starts, from the point where where you want to understand, okay, what is this data about. It starts with clean data. So that is, so remember this thing, the data has to be clean. It has to be it has to be available on time also, no? So if I want to know when is the admission starting for the next year, so maybe for this year, let's say it starts in August, you can't give me the information in October. The value of the data is lost by that time, right? So what is the point in giving the data? So data has to be given on time. The data has to be clean, means it has to be perfect. Whatever imperfections are there, that is where your data analytics will come into place. That you collect the data, but before you give it to anybody or any client or anybody who wants to use the data, it has to be in a clean format. It has to be given in the timely format. So that means it has to be accurate, it has to be timely, it has to be useful, it has to be used in right context, right? So for example, when you say in the right context, if you say I want to know everything about moti. Now what is moti? Moti is it a soap moti you're talking about? Is it a moti dog you're talking about? Is it a moti gold you're talking about? What are you talking about? Maybe your data is clean, but what context? If I told you I want to get a list of I want to know everything about moti, but when I wanted the information about the moti the dog, you give me the information about moti the soap. It's useless for me. So when you are into data analytics, or especially when you say data analytics, you are getting into the area of big data. Okay, when you're talking about big data, small data everyone can manage, and of course we want to be skillful in that also, where we use all this data warehouses and everything, but also we have to be able to skill ourselves to manage a big data also, which where scaling, it has to be scaled enough to absorb that kind of data. So whatever data you're absorbing, it has to be kind of clean, it has to be given in the right context, it has to be given in the right time, it has to without any and it has to be complete also, no? For example, what is complete data? Complete data means I'm referring to complete data set, which means I am supposed to know the list of all the students in the class. If you just give me the name of 2 students, will that data set itself is a data now, but is that data complete? No. So now everything is okay, you're giving me on time, there's no mistake, data is very clean, but you did not give me the entire data. So how can I judge? How can I, if I say the count of the student is, you just give me 2 students name, then I'm saying it is the answer is 2. My answer will be wrong. So whatever, so make sure the data is complete. So so this is also important in the area of data analytics, or even in data science. So wherever you're using data, all these things, as a data person, you have to know, okay, okay, it's just not about sending the data, but am I sending all the data or not? If I'm not sending all the data, am I sending it in batch format? Let's say, maybe I'll send names of 10 students now, and then 10 students tomorrow, and maybe the data set is building up over time. So that is also okay, but you have to know how you're ultimately the information that you're generating out of it, it will be valuable if you know how the data is flowing, how much of data is flowing, is it a complete data, is it a clean data, is it a data given in the right context. Everything is important about data, because useless data is useless for anybody in the world, no? So it is no use. Okay, so the next line says data can be in the text form or binary form. So I want you all to what do you understand a difference between text data and binary data? Give me one example of a text data and give me one example of a binary data.
Binary data is in the form of zeros and ones.
Okay, good. So binary means zeros and ones, so everything is zeros and ones. So this itself is data. Okay. Any other difference? Anybody else? What do you understand when you talk about text data, binary data?
So any name of a person or name,
Okay.
place name or something
Okay.
can be in text data.
Okay, good. So name, place, this is also data. Very, very good. So I know the name of the place. Oh, good. Any other?
Text is in readable format, and binary means it's zeros and one. It cannot give any information.
It is an unreadable format. That is what
Right.
you're trying to say. Very, very good. Very good. I cannot understand. It is still data, but I cannot understand zeros and ones. This is you're very close.
Machines only.
Yeah, it can understand, only machine can understand. Very good. Anybody else have any other example or different understanding? Any other example? So Pooja, do you have any example of an unreadable binary data? What is an unreadable binary data example? Anybody? Okay, so let me show you one file, and you tell me whether it is text data or whether it is binary data. Now ideally, if I this is basically all the video files, MP4, MKV, this is, let's say, MP4. So I was recently singing a song and I recorded here, so this itself is a data, right? Now when I click on this, this data is opened by the software, which means that only that software can read the data. So if I open this, you all will not be able to hear maybe. So you see I'm singing something, and I can hear the sound and everything. Okay, so the thing is this data read by the, so the question is this, who is reading this database? Is it read by the audio software or is it read by the database? Who read this information from this file and actually gave you it in a presentable format? Who did that exactly? So there was a music file, right? And music plus sound plus video it was. So you saw this file in the .mp4 format. Can MP4 format data? How does the MP4 data look like? Who can read that kind of information? It is if you actually, ideally we click but we don't actually see the file. If you right click on this and you say open with, I'm purposely not going to choose any like audio or a video software. I'm purposely going to choose a notepad. That is your notepad is your best it reveals all the it actually shows you something, how things are inside. So I'll open it in Notepad++. That is one of my comfortable tools. So whatever software I'm talking about, make sure you have it on your box, so that when you have to practice or anything. So you see, this is all data. There's something in this. It is like all I can't understand this language, whatever they have written. I cannot even read. Some characters are not even English. You see, some of the character is like WW something is okay, but some other special characters over here. With a some tick on the top and everything. So this data actually is actually in the form of zeros and ones. Actually, so if you can convert this data into zeros and ones, but when you are trying, why it is showing in text format? So first of all, this is a binary data. This is an example of a binary data. If you say what is an example of a binary data, all your music files, videos, and anything that is non-readable, that's a good word, right? Readable and non-readable. This is still readable, but it is like a kind of a junk. I cannot understand. Only that software can understand, because the software is not trying to read these characters. The software is trying to read the binary at the lower level. Every binary, how much zeros are there, how many ones are there, what does this 0 and 1s mean? This zeros and ones means I have to play a so and so frequency. That is how your sound is produced. Or this zeros and ones means I have to produce this color on the screen. So everything is information trapped inside this. All your video pixels, all your audio frequencies. Audio is nothing but your set of frequencies, right? The way you talk. There's a set of all the frequencies that you use while you're talking, and that gives you a different sound output. So all those numbers are trapped in this, and that is what that software is trying to do. It is trying to read all the zeros and ones, because if you try to actually store it in characters, it may take a bigger size. So we'll come to that, but music file and video file is an example of a binary data. So can a database understand binary data? Question: can any database in the world or understand binary data? Can anyone answer?
Yes.
How? Have you like, can any database tell you what are the frequencies of the sound that is used in the video file? What is the image of each frame, or anything about? Do you get how long is the video? Can a database understand if I give a database, if I upload this file and store it in some field, so the kind of field that you're going to use in a database for this kind of objects is blob field. So you have a string field, integer field, but blobs are used to store big your binary files. So binary large object we say. So remember this. So this is a data type. So you spoke about text and numbers, but this is also a binary data can be stored in a database in this type of field, data type. So the question is, I can store this data, but can can I get a count? Can I run some query on this and say select star from, let's say this blob field was my name of the column was my video, or so can I do something like select count of something my video something dot frequency or something? Can I play any magic with this, scrap any information so from my table? So So the answer would be actually no. You cannot read the binary data. That is not the data. I mean, database cannot read the data, that thing. If there is some software such as your audio software, sound software, that can open up a binary file and read pixel by your bit by bit and understand what this data is all about. So you require special softwares to interpret what the binary data contains. So how do, so the question is now, how does let me just remember this. So lot of photos get uploaded. So let's say this is photo number 1, photo number 2. All this binary data is getting uploaded in Facebook or all the social channels. So Facebook is collecting all your photos from all over the world. Let's say, how is Facebook able to? So Facebook collects this, means it has to store this all these images somewhere. First of all, it has to use some storage. So let us assume it is using, it is storing everything in a database or something in the backend. So there is a database over here, and so all these your images, they are stored as blobs inside your database. How is Facebook able to tell who is looking at what image and those kind of information, or what is there in the video? You must have seen, there is a dog in the picture, there is a human being in the picture. This is ultimately a data, data of binary data. Everything is there. That whether there is a dog in the picture is there in this binary format. How did Facebook aim to know that there is a dog in the picture? Anyone?
So,
Yeah, go ahead.
is it like it has been assigned as a value of each picture? Is it assigned to a value and then put it in
something like that. Yeah,
table?
but how it is done, so basically what you're talking about is, I cannot read the data, okay, but I can define a metadata. So this word is very important. Metadata is equal to data about data. So when you are trying to store any binary data, you also store the metadata along with that. So the metadata could be what all entities or human beings or mountain or type of picture, all this information. You try to get this information, metadata. So the metadata has to be created. So then the only question is, how do I create this metadata? So for that metadata, you have to use if it is a photo or something or video also, we have to use basically image recognition programs, so which can read this binary data. So you're basically you can take this data, give it to image recognition program, and in response, let me just draw a thick line. In response, so you read this data. First of all, collection of data is happening. Whatever data is been given by everybody on the Facebook all over the world, that has been collected and put in one place. So that we are assuming that data is good now. That image is good, as I told you, right? It has to be clean data. So that data is clean. Now once data is clean, you can do a lot of things with that. You can give it to a machine image recognition program, and that is a different field altogether by itself, image recognition. So it's not only about this kind of images, right? Your medical x-rays and your scan reports and everything. Even your text files are PDF files. PDF file is also, though you can read the text, it is still binary. If you open up a PDF file, any PDF file in Notepad, it is, again, you will see it is not readable, and that's why PDFs are not like notepads. So PDF files, your text file, if you open a .txt file, a normal my file.txt, it opens up, that is readable also, and that you can say maybe it is stored, that also I would say is that is a little difficult to predict, very difficult to, to say, show you that it is still binary. but you can assume that is close to the most readable. Your text file is close to the most readable text format, whereas PDF is containing not only the text data, but it is also because when you have a PDF, it is converted into images. So your text is, that conversion is happening into images, and that image is binary information. That binary information is trapped in this PDF. So so that also is a binary file, and X-rays and everything, images, where the hospital comes and it receives an X-ray report from so many patients. It has to be given to some machine image recognition software, which in turn will tell what is there inside this image. So if it is a medical X-ray, then definitely you can use a specialized program that can look out for some medical like what is wrong with the person, right? Somebody is admitted, this is an X-ray. Why is there for example COVID, right? When COVID happened, they knew the virus, but they didn't know much information on it. So but ultimately what they are trying to do, they are trying to get an image of your that virus inside your system. That virus is nothing, and they produce an image out of it. They are able to do this much. Now in that image, can they, so there is a lot of information in this, and can some human being go and read each of these dots and then take these 3 dots and tell what is, if there is a correlation? I can see this black dot, red dot, red dot repeatedly, let's say I can see in the system. So I can probably, so just let me just copy this a little bit more. So you're reading this report, and grab this, yeah. So you're reading this report, and all over the place you're seeing a occurrence, a repetition of black dot, red dot, red dot. A image recognition software will immediately detect this and do it more quickly than a human being. So that's why we require machines, because a machine can see what humans cannot see. Machines can see probably little, we are able to see little broader, we cannot see the fine prints. That's why I think that these people, I'm not sure whether they're called radiologists or something, their job is partly, of course, radiologists, they feel machines are taking over, but definitely we require still human beings to give a judgment on what the machine is interpreting is okay or not. But the point is, the machine is able to recognize a pattern in the data. What is the pattern over here? The pattern they are saying is a black dot, red dot, red dot. This is appearing continuously. What does this? Maybe we know something about it, maybe we don't know something about it. That is a later task, what we want to do with this. But we are seeing a pattern. The machine learning program can definitely detect this kind of stuff. But what a machine learning program has to be given, an image recognition, your X-ray, right? X-ray has to be given in, or your whatever that your image is, and that image has to produce a metadata, and your metadata can be, I can see a red dot and one black dot and 2 red dots, and maybe the meaning of 1 black dot, 2 red dot means the person is having some kind of a sickness, or maybe it is healthy. Whatever the judgment is, that metadata has to be tagged to the binary data. So metadata plays a very big role in binary data. Binary data inside an audio binary file will have a different type of binary, different type of data. Data frequencies and different number of bits that they will use. A PDF file will use a different number of bits, and different it is where the text is, which location it is it black color, white color, all that kind of metadata the PDF file will contain. So but to use binary data, you are required a metadata. There is no particular structure inside a binary data. Did you see a particular order in which when I open this file, can you see any structure? A structure is like, I'm seeing a human being, I'm seeing 2 hands, 2 eyes, that is a structure. A structure is something like, this is this is a food, and there is a dal and the rice, that is maybe some kind of structure. This is like gibberish to me, this is actually meaningful, but this is, for me it is gibberish because I can't make anything. So this type of data, binary data, comes under the category of unstructured data. Now our databases can manage normal like text data, numbers, okay, this is okay. We can handle also big data, we have a lot of data, and but when the data, so if it is structured, even if it is semi-structured, we can play around it, and we can the machines can understand. But when it comes to unstructured data, we require a metadata, and metadata has to be generated by some program. A database cannot do that job. Depending on what type of binary file we have, whether it is a PDF, whether it is audio, whether it is a video, or any other binary file, something which is not readable, we require the relevant program to dig into that binary and gather the data out of it and produce a metadata out of it. It is this metadata which Facebook then works with. So we can have with select star from metadata where is human being present equal to true. This will return me what? This will return me all the pictures which where the metadata this has been evaluated to be true. So that's how Facebook is able to tell whether there is a human being in the picture or not a human being in the picture. But do you understand one thing? First of all, lot of data is getting collected, generated from this right hand side of the screen and going into Facebook. So that is one problem. The second problem is I don't know about this binary data, so let me give every file to this image recognition program. So you can imagine how much is the load falling on the on that program itself. So that program also will crash. If you keep on giving files to it and say, give me the metadata about this file, give me the metadata about that file, how much can it run, or can it do multiple things at a given time? Even a machine is having a limited capacity, a limited storage, a limited memory, a limited time it can, after some time it gets heated up or something. So a program also can crash. So that is again one challenge, that not only we still did not get our output, we get our output only after the metadata is generated, number 2. Number 3, the metadata is created for all the files, which means I'm going to have a million rows in this. So you can imagine if I fire a query like this, the one which I gave right now, select star from metadata where his human being equal to true, it will take how many seconds? If it has to read all the million rows, and this, okay, there are 10,000 rows, it has to read all the records, so how much time it will take? If it takes just like 1 hour or something, then Facebook, then it is no good. Everything is moving very fast. We want to know what is happening now. The data has to be given on time. So that again becomes a challenge. Not only I can fire a query, everything is working fine, but I'm not able to process it on time. So processing everything, storage problem, collection problem, all these are problems of data analytics over here. The presentation problem, how do we present this data, to whom we are presenting the data. Then is the data whom in the sense, we cannot, some data may be confidential, some data may be public, right? So you have to remember this term also. This is in terms of privacy, you can say, yes, what is public data, what is we'll talk about it at the time, but not all data can be shared publicly. So for example, ideally nobody should, for credit card companies, for example, it cannot take your name and address and store it in a format which is readable. It has to be stored in a binary format. So you can take your text data, convert it into some binary format by using some encryption logic, and store it in a non-readable format. So there are so security restrictions also. What standards do we follow? So you cannot store all the personal information of anybody and everybody in a database in a text format, because if anybody hacks the database, then definitely all that data is gone. So for example, there was a leak in the Aadhaar card information, right? Why did that happen? Because the data was not protected. Everything was okay, the process was okay, but the data was not protected in a secure format. It was in a readable format which could be easily extracted by all these middlemen and given it to and sell it to somebody. So data privacy is a separate issue, but as a data person, that is also your concern. So data, not only it has to be clean, it has to be protected also. So that is what metadata is all about. And that is what is the difference between your text data and binary data. Binary data usually falls under the category of unstructured data. Now the bigger truth is 80% of the data that is generated is unstructured data. I told you 80% of the data is generated in the last 5 years. The second thing is also whatever data you have generated is unstructured. We have never dealt any, we are having computers and IT for such a long time. We are dealing with structured database, SQL, but how much data are we trying to work on? We are working only on that 20% of the data. 80% is still databases cannot handle it. We require special. Now we 80% of the data that is generated in the last 5 years is unstructured, which means it is in the binary format. These are all data which is coming out from the social media, all the files, your websites, your everything has been tracked. Whatever you're doing, where what software you're using, what do you like, what food you have eaten, all this data is getting collected also, but it's not everything is coming in the text format, or it is mostly like broken or maybe unstructured format. So but mostly we are talking about 80% of the data, we're talking about unstructured binary data. So how do you manage this 80% of the unstructured data? Will a SQL database be enough? No, SQL database cannot manage unstructured data. So who can manage unstructured data? So we have to create a metadata kind of program, and which database manages unstructured data. So there is no database itself who is managing the unstructured data. So there is something known as in AWS data lake. So this is one cloud service, AWS data lake, which tries to not only manage structured data, unstructured data, it is creating a platform to manage everything and also relate to each other. Because I may have an image which must be connected to this particular other profile. Is there a connection? Yes, there is a connection between this unstructured image versus the structured name of the person. These two are connected, and that is where data lake is a place or service where you can upload a video file, you can upload you can do all this magic over there with unstructured data plus semi-structured data plus structured data. So what is the difference between the three, we'll see later, but what I'm trying to talk about is 100% of the data or type of data can be managed by AWS data lake. Whenever we studied our databases in our colleges, or we have mostly touched upon SQL data, and definitely we have not really seen it for all the data. As a data person, you should be comfortable, first of all, with what is data, what type of data. Is it text data, is it number, is it binary, is it structured, unstructured, and what services should I know to play around with this, how can I create some information out of it. If you can take all these images and put it into data lake and produce some good BI screen, then you have achieved your goal. So that is what your skill set should be. Let me do one experiment with the data lake. Let me take the structured data, let me see how I can do it. So those are the things we have to learn, and those are the things of companies, or something that will impress. So with that, I just I don't want to move forward now. Any questions anyone has? Do you understand the difference between text and binary now? Oh, I'm not audible. Okay. Okay, so you understand the difference between text and this. Do you know what is metadata? Can somebody explain me or just tell me what is metadata? Siley, you there? Can you hear me? Okay, I can't hear. Okay. So, Vasant, what did you understand? What is metadata? What did you understand about it?
Sir, metadata is basically data about data, and example is like it can be sir a date and size and formats.
Yeah, so it is some file you have got, some especially metadata can be created about everything in the world. Like you can create a metadata about a website, like what type of website this is, and it is a financial website, or also it can be metadata can be created from a on a binary data. But when for us metadata is important, especially because binary data cannot be read, so that is what it is, data about data. So this definition is so important. What all these questions can be asked in the interview. Okay, what is the difference between text and binary? What are the challenges you can think a data analyst can face? So you can say collection, storage, your unstructured data, those kind of things. So those are the challenges. Or what the question can be, what is a metadata? So what I want to understand, so this is all for the lecture, and but also let me first stop recording.